Yes, so for your full wave project, this is what I want you guys to do. We are trying to make it more practical. So you went for an interview, and the manager there wants you to design a charger, right? So you're doing the full wave bridge rectifier. So the first thing I want you guys to do is to first make a design of what you want to do. I've already given you the framework of how it will be like, but you have to do your own design, how you build it, right? So the first thing I want you guys to do is to draw how you want it to be like. So for the project I am coming to do, this is how my layout will be like. So I have my terminal pin here, right? For those who don't know terminal pin, this is the terminal pin, right? This is a terminal pin. Then this is the breadboard, right? Or the breadboard for temporary use, but this is a strip board. Are you okay? Then we have a diode, right? Those who don't know what this is a diode. So you can see there is a gray strip here, right? And for the diode, this side is the negative side. Is that okay? This side is the negative side for the diode. So where there is no gray strip, that side is positive, and where this side is, that's the negative. Are you okay? Then we have our heat sink. And we have our voltage regulator. So this is a 7805 voltage regulator. That means that it will give us a constant 5 volt output. Are you okay? So we will connect this one to our heat sink so that when it produces heat, this guy will dissipate them. Okay. Then there is our electrolytic capacitor. Are you okay? So this is our positive side, this is our negative side. In case you have both of them having the same length, always check the markings. Where the gray stripe is, this side is the negative side. So always check in case they're having the same length. But if they are not having the same length, always the longer one is the positive side. This is our electrolytic capacitor. And this is our ceramic capacitor. That's our 104. That's 10 microfarad. Yes, this is our electrolytic capacitor. So now we have all our components. The only components left is our USB. That's this one. That's the USB female breakout. Are you okay? So the first thing you need to do is draw a layout of how you want your work to be. So this is how I want my design to be, right? So now this is my terminal block. So my terminal block is here. And now I come to my 4 diodes. So this is one diode, another diode, another diode. So I can see that from this side to this side is positive and negative. Are you okay? So I trace it to my work. I must see positive and negative. Is that okay? Positive and negative. Then when I come to this side too, I'm having positive and negative. So positive and negative. Is that okay? Then when you come here, it's negative and positive. I'm having negative and positive. Then when you come here, I'm having negative and positive. So negative and positive. Right? So how it works is current comes in, right? This side is reverse bias, so the current flows through this side, come and pass through your capacitor, then come back. Because this side is having a higher potential as compared to this side, the current will pass here, then go back. Is that okay? So that's how we are coming to do. So we have 2 inputs, then 2 outputs going out. So this is our inputs coming in, and it's connected to this side and this side. So I have 1 and 2. So my input is connected to 1 and 2. So now let's check how I soldered that part at the back. The soldering, there are a lot of ways you can solder. This is just for illustration, so I've added a lot of solder so that you guys can understand. But in place of solder, you guys can just use the cables I'll give you. So you have strip wires here that you guys will be using, right? You can just cut them into pieces and pieces. And those using this type of strip board, I gave you a different type of strip board. Those using this one, let me explain something small. So you see this coated copper here. It means that all this place is connected together. All this place is also connected together. Please take note so that you don't short any of the work. So let's use our multimeter to test and see if they're on the right path. So just turn your multimeter on you put it at continuity, then you test and see. So you can hear the sound, meaning that it's short. So this side and this side, right? So you can hear the sound, meaning that this whole place is shorted, right? Now this side and this side too, you can hear the sound, so meaning it's shorted. But this side and this side is not shorted, so you can't hear any sound. So please be mindful. In case you want to use any other place, you just have to scrape off this metal, this copper, right? You just have to scrape it off, and that place won't be connected together. Are you okay? So now let's go back to our board. So from this side, that's this side here, we move straight to this side. Are you okay? So this side is connected to this side. That's from here right to this side. That's the same thing we've done to the back. So this side is here, then this side is also here. So right from here we came here, so right from here we are here. Is that okay? Then the other side, that's this side, that's the other part of your terminal block. That one goes to the top part, so it just follows suit to this side. So now we have this guy and this guy being our input, right, from the terminal block. Now the output is between this one and this one. Note that they are not on the same line, so they are not short together. This guy is on a different part, this one is also on a different part, so they are not shorted together. Okay, now let me continue. So now from this side, we connected from this side to the negative of our, from this side to the negative of our electrolytic capacitor. So we can see from here, we connected it to the negative. Can you see? This is this line. So from this side, it's connected to the negative side. That's this point. Are you okay? And since this whole place is connected together, it's like a ground. Are you okay? So I can connect to a different side, but not, let's wait for now. And then the other side, that's this one, is connected to the positive side. So from here, it's connected to the positive side here. Are you okay? So now we are here. So here and here. Are you okay? Now to the voltage regulator. You see, the voltage regulator works like a two-port system. So we need two inputs, two outputs. Are you okay? Just as when we were doing the transistor, we said the transistor is also a two-port system. So we need two inputs, then two outputs. So we need to make one of them common. Hence the configurations we are having. So for this one, we make the middle one the common. So the first and the second will serve as the input source, and the second and third will serve as the output source. So we have 1, 2, 3. So the input, the first and second, you see, they will serve as the input source. Then the third and second will serve as the output source. Are you okay? Make sure they are not connected together. Okay. Now when you come here, I've made sure I've demarcated, I've scraped off this copper platings there so that it doesn't touch each other. Right. So I'm having 1, 2, 3, and this one, that's the one from the positive side of our capacitor. That's this one, is connected to 1. So from this one we move to 1. Then the one from the negative side, that's this one, also move to 2. Is that okay? Now the next thing we need is 2 and 3. You see, 1 is not connected to 2. Are you okay? There is a space there. You can see there is a space here. Are you okay? There is a space here. And the next thing, that's the output we need. The output we need from this side and this side to our ceramic capacitor. Are you okay? So now the ceramic capacitor is here between this guy and this guy. Are you okay? So as you can see, we connected the middle one to one part of the ceramic capacitor. Then we connected this one to the other part of the ceramic capacitor. Is that okay? Because the ceramic capacitor is non-polarized, so you can connect them any way you want. So now we also have them connected to the ceramic capacitor. Now we are here. Now the only one left is our USB port, and our USB port, since you are not using any data cable, we just need our VCC or our V-bus and the ground. Okay, so the middle part, I'll just take them out. Are you okay? Then I'll connect the far end of the 2 1. Is that okay? And that's all that you guys are doing. So you just come, you explain, show your diagram, how you connected from your diagram, and you build, then you are good to go. Is that okay? Thank you.